Finding the slope given the graph of a line in quadrant 1 that models a real-world situation. So this topic is going to continue our discussion of rate, but merge it with a new idea called slope, which is just the rate of change. So it's the ratio of the change in y over the change in x. So let's see how we're going to work with this. The sugar sweet company needs to transport sugar to market. The graph below shows the transporting cost in dollars versus the weight of sugar being transported in tons. So if you look at our graph, the weight is represented on the x-axis and the cost is represented on the y-axis. But before we get started, let's look at what slope is. Slope is the ratio of change in y values to the change in the x values. So what we would do is we would find how our y values change and compare it to how our x values change. And it's described as the rise of the graph over the run over the graph, which is rise over run. So if you think of the rise as going up and down, that's our y values. And if you think of running as going left to right, those are our x values. Okay? And so slope is going to equal rise over run. So let's answer our questions. How much does the cost increase for each ton of sugar being transported? Well, let's look. It starts at 500 and it goes up, and if you go to 1 ton, it crosses at 2,000. So to find the change, we're going to subtract, and that might be a good thing to note. Change means subtract, and I think we've already talked about that quite a bit. Change means to subtract. So we're going to subtract our two y values here. 2,000 is what happens after 1 ton of sugar, and it's a starting point of 500. So we're going to subtract those. So we'll get 2,000 minus 500, and that's going to give us a change of $1,500. Okay, that's how much it costs to transport 1 ton of sugar. And if you look, it happens again. If you go from 1 to 2, 2 crosses at 3,500. So from 1 to 2, it goes up $1,500 more dollars. So our answer is going to be $1,500. And I got that by subtracting my starting amount from 1 hour or from 1 ton of sugar. So I did 2,000 minus 500. So to find the slope of the line, we'll just say, what's the rise compared to the run? So if you look here, if we'll start at 500 and we'll go up 500 to 1,000, so it'll be 500, 1,000, 1,500, and then if you look, it intersects the line at 1. So our rise, we'll say slope equals rise over run. So our rise was 1,500, and it ran 1 space over. So our slope is 1,500 over 1, or just $1,500. So slope is a ratio compared to the rise over run, and the rise is our y values, and our run are our x values. So let's make that note. Our rise represents y values, and the run represents x values. And we're getting into a part of math that is really, really fun to work with. Slope and linear equations. Okay, so this is going to be rise over run.